Hey everyone! In this video, we're going to be taking a look at how to find the derivative of functions that involve sine or cosine. So along with our theorems for the derivatives of sine and cosine, I would like to use some of the other rules we've established, including the product rule and the quotient rule. And I want to take a look at a couple examples where we need to put all of that together in order to find the derivative of the function. So to start off here, let's just remind ourselves of the theorems for the derivatives of sine and cosine. So we have a theorem that says that the derivative of the sine of x is equal to cosine of x. And we have a similar theorem for the derivative of cosine, which says that this is equal to the opposite of the sine of x. So these are two very short, simple, and sweet theorems that allow us to find the derivatives of sine and cosine. So let's take a look at our first example. So I have a function f of x, and this is equal to 2x times the sine of x. So I have two different pieces here. I have 2x, and I'm multiplying that by the sine of x. So I'm definitely going to need to use the product rule to find the derivative. So why don't we just write the product rule down just so we remember. So if I have a function that can be written as the product of two other functions, then the derivative of this is equal to the first piece times the derivative of the second plus the derivative of the first piece times the second piece. So now using that, let's go back and we'll find f prime of x. So following the product rule, our first piece is 2x, so that one will stay the same. And then we're going to multiply by the derivative of the second piece. So using our theorem, the derivative of the sine of x, this is equal to cosine of x. And then we're going to add the derivative of the first piece. So the derivative of 2x using the power rule, that's equal to 2. And then our second piece here will stay the same. So we have sine of x. And that's actually it. So here's the derivative of our function f using the product rule. All right, moving on to our second example, g of x. In this case, I have the quotient of two parts. So I have the cosine of x divided by x. So in this problem, we're going to need to use the quotient rule for derivatives. So again, let's write that down so we remember. So if we have a function that can be written as the derivative of two other functions, then this derivative is equal to the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator all over the denominator squared. So let's go back to our function g of x, and we'll follow along with the quotient rule to find our derivative g prime of x. So starting off with the derivative of our numerator, so using our theorem, the derivative of cosine is equal to negative sine of x. And then we'll multiply this by the denominator, so multiply by x. And then we're going to subtract the derivative of the denominator. So the power rule again, the derivative of x is just 1. And then we'll multiply this by the numerator, which is cosine of x. And then in the denominator of our fraction, we have our denominator squared. So x times itself, we have x squared. And then just a little bit of rewriting and simplifying. So g prime of x, this is going to be equal to negative cosine of x minus x sine of x all over x squared. And here is our derivative of g of x found using the quotient rule. And let's take a look at one more example where we're going to have a function that has both sine and cosine in it. So the last example I have, it's a function h of x, and this is equal to the sine of x divided by cosine of x. So again, we have a quotient, so we're going to need our quotient rule, but this also involves both the sine and cosine. So we have h prime of x, using our quotient rule again, to start off with the derivative of the numerator, so the derivative of sine is equal to cosine, and then we're going to multiply this by the denominator, which is the cosine. We're going to subtract our numerator times the derivative of the denominator. So the derivative of cosine is equal to the opposite of the sine. And then this is going to be all over our denominator squared. So cosine times itself, I'm going to write this as the cosine squared of x. Now let's do some simplifying and see what we end up with. So in the numerator, cosine times cosine, we have a cosine squared of x. The second part, we have a negative sign times a negative sign. So that's going to turn into plus sine squared of x. And now this is still over our cosine squared of x. In the numerator, I hope that looks familiar because that is the Pythagorean identity. So sine squared plus cosine squared is equal to 1. So we have 1 over the cosine squared of x. And 1 over cosine squared, that is equivalent to the secant squared of x. So we end up with h prime of x is equal to the secant squared of x. Now, just want to go back up to our original problem to take a look at this. So sine over cosine, this is actually the same as the tangent. So the derivative of tangent is equal to secant squared of x. So that's another theorem that we can use as we move forward, looking at functions that contain trig ratios.